doctors at this health centre in the small town of Ottery St Mary are pioneers in the use of computers in their surgery. Now they're doing this in conjunction with the Exeter Community Health Services computer project. This is a project involved with the storage of medical records on a computer. Now we've come to have a look at their system from the point of view of files and file processing. And in particular, we're going to have a look at how indexes enable the doctors to retrieve data quickly and efficiently from their files. But first of all, we asked the doctor what he actually needed a computer for.
In 1974, we started keeping our records on a computer instead of the more familiar National Health envelope. This patient here, Bertha Bloggs, is a dummy patient because records are confidential and I'm not going to show a real record. But it shows very exactly the kind of records we used to put up with. Illegible handwriting, difficult to keep in the right order, a lot of information, all unsorted. And good stuff such as, well, she's allergic to penicillin, could easily be missed in this kind of record. With the computer record, important points can be highlighted and seen very easily, and the general presentation and sorting of the record has enabled us to solve this problem very well. Mrs. Bloggs, please, room 4.
Using a computer is part of the everyday routine for the doctors here. Each patient on the appointments list has a number. It's the number which identifies the patient to the computer. Within a few seconds, there's a summary of important information on the screen. The doctor can see straight away that this patient had pulmonary tuberculosis in 1944. And all the other major incidents are displayed, together with the year and notes about each episode. And right at the top of the screen, priority information that the doctor must have. With the computer system, the allergy to penicillin won't be missed.
Hello.
Hello, Doctor.
How are you?
Very well, thank you.
Good, good. The new tablets haven't upset you at all?
Not at all, no.
Fine.
No.
This is just a routine check, isn't it?
Patients see the computer terminal as just another of the doctor's instruments. And the doctor can use it in several different ways. This screen gives a history of the patient's blood pressure of the last few visits. It's displayed as a graph.
Just the routine check.
Yes.
Good, that's excellent.
Good.
No need to change the dose at all.
No.
Go
No.
on just the same.
Whenever the doctor wants more information or wants to change something, the computer responds within seconds. It's called an online system. We're going to look at how it finds the correct patient so quickly, when information about thousands of patients is stored in the system.
Bye-bye then, Doctor.
Goodbye.
Bye-bye.
See you in 3 months.
Yes.
When we made this film, the doctors were using a large computer at a hospital in Exeter, some 20 miles away. That's where we spoke to the director of the project, Jack Sparrow.
When we designed our real-time system, there were two problems that we needed to account for. The first was we needed fast response. The second was we never knew what data was going to be requested at any time by our users. The users in our case were GPs, the doctors, and their receptionists from Ottery St Mary Health Centre. This meant that there were certain techniques that were not available to us. For instance, we could not use magnetic tape. Using of such tape would perhaps have limited us to minutes of response while we wound through the tape to find information that was at the end of the tape. The media, therefore, we chose to use was the exchangeable moving head disc.
So discs like these are used to store the patient records. They're loaded into disk drives, and then the information they contain can be accessed by the computer. To see just how it works, we've dismantled one of these units. The disc pack itself consists of 11 discs, stacked vertically and supported on a central drum. Each disc is coated with magnetic material for storing information. To increase capacity, both top and bottom surfaces are used. And these are the heads that read information from the disc. Each head floats a fraction of a millimetre away from the disc's surface. There's one head for each surface, but for clarity, on this unit we've removed all except 5 of the heads. They're positioned between the discs by a large electromagnet, and this is the mechanism which moves the heads in and out to the correct position. Let's see how the process works for reading information from the disc. When the disc is in use, it's spinning rapidly, 40 times every second. So if the head stays still, each head traces out a circular path on the disc. The circular path is called a track. The head reads information from the track as the disc rotates. For convenience, each track is divided into sectors. To read the information from any one sector, we must wait as the disc rotates until that particular sector passes under the head. That works for the sectors on one track, but there are many tracks on each surface of the disc. To read sectors on the other tracks, the head moves in and out. What happens when we want to read a particular sector? First, the head must move to the right track. This is a slow movement compared with the speed of rotation. When the head reaches the correct track, it stops and waits for the sector to come round. To read another sector, the process is repeated. On average, moving the head takes 3 times as long as finding the sector just by rotation. The disc pack as a whole has several heads in a unit. There's one head for each disc surface. The heads always move in and out together. So for each position of the head unit, we can read one track on each surface. A group of tracks like these, one above the other, is called a cylinder. So how can we read a particular sector? First, the head unit moves to the correct cylinder. Then we wait for the sector to come round. When it does, we use the particular head for the surface containing that sector. So, using magnetic discs, it's possible to read any item of data without searching through a sequence. Access time is fast. The mechanical movements take just a 20th of a second. But to use this speed needs organisation.
To take advantage of the speed of the discs, we need to know exactly where the patient information is stored. When the doctor wishes to access the patient record, he keys in a number at his terminal. This number must be used by the computer to find out where the information is held. To do this, the computer uses an index to find the location of the cylinder and sector where the data is held.
The patient number index is stored on the disk in the same way as the medical records. To see how it works, we need to look at what's inside the index. The entries in the index correspond to the range of numbers which can be allocated to patients. Each patient is assigned one of these numbers when he registers with the doctor. Then the corresponding entry lists the cylinder and sector where that patient's medical record can be found. For example, the number 901 has been allocated to a patient. The entry in the index says that the patient's medical record is in cylinder 3, sector 7. The number 902 has also been allocated. This patient's record is in cylinder 2, sector 4. Number 903 is different. The entry for 903 lists cylinder 0 and sector 0. This is a special code to show that the number hasn't been allocated. Number 904 has been allocated. Cylinder 1, sector 6. And so on. So let's see how the index works when the doctor types in a number. First, the number is transferred to the working store. The index is in backing store on the disk, so that must also be transferred to the working store. In working store, the index is like an array. The computer can go directly to the correct entry. The medical record is in cylinder 1, sector 3. Now the computer can access the disk a second time. This time, the patient's medical record is transferred to working store. And now it can be displayed on the screen for the doctor. So to get the record for a patient, the disk is accessed twice. Once for the index and once for the medical record. Starting with the patient number, retrieving the medical record is a very efficient process. It's used daily at the health centre. Of course, clinical information like this is confidential. Special passwords make sure that it's only available to doctors, but some parts of the system are used more widely. Much clerical work at the health centre is done by receptionists. They use the computer system for preparing repeat prescriptions. Some patients take the same drug for several months on end, so they'll need new prescriptions at regular intervals. The screen shows that this patient takes 2 drugs and needs a new prescription each month. That information was entered by the doctor. If the receptionist types a letter R against the drug, she can ask the computer to prepare a repeat prescription. The computer always checks that the request is valid. If it is, it prints the prescription, complete with dose and quantity, from the medical record. For each prescription, the receptionist uses a patient number to display the correct screen. That way, she uses the computer's index to the data. It saves a lot of the doctor's time. All he has to do is check the prescriptions and sign them. But sometimes, receptionists use the computer in a different way, especially when making appointments.
Doctor surgery.
When a patient telephones the surgery, the receptionist must find the patient number. This time, she types in a name. Then, the computer lists a number of similar names. She selects the correct one. And the computer displays the number.
Thank you very much. What time would you like to come in? And who is your doctor?
This is a job which can't be done with a simple patient number index.
11:30 tomorrow morning.
We had an additional requirement to access the patient records through names. So in 1977 we introduced a new index called the surname index, whereby patient records could be obtained by typing in the surname. However, names can be rather similar, and therefore we display a set of names in alphabetical order from which the user can select the correct one.
This ability to display similar names comes from the way the surname index is organised. The main part of the surname index contains a list of patient names in alphabetical order. With each name, there's the patient's date of birth and the corresponding patient number. So this could be regarded as a sequential file, and the computer could search it in sequence, name by name, until it came to a match. But there are thousands of names to search. The names themselves cover several cylinders on the disk, so a straightforward sequential search wouldn't give a fast response. To speed things up, the list of names is divided into more manageable portions. The names in each cylinder are grouped together. There's a group of names in the first cylinder. A group in the second cylinder, and so on. To show which cylinder contains the required name, there's an index. The index contains the last name in each cylinder. For example, if the last name in the first cylinder was Andrew, then that would be the first name in the index. If the last name in the second cylinder was Blimp, that would be the second name in the index. And so on. Now, finding a name is faster, because we don't have to search through the whole list. We search the index first. Suppose we're looking for blogs. It's after Andrew. It's after Blimp. But it's before Cardew, so it must be in the third cylinder. Now we can search the third cylinder until we find the name we want. A file structured like this is called an indexed sequential file. So to use this indexed sequential file, we first search the index. Then we use the reference to the appropriate cylinder. And finally, we search that cylinder in sequence until we find the name we want. In fact, this is a very simple type of indexed sequential file. A lot of time is still spent in searching. Now, to reduce this time still further, most indexed sequential files use more than one index. The system at Exeter uses two, a high-level index and a low-level index. This cuts down the searching even more. First, we search the high-level index. Then, we use the reference to the low-level index. Now we only have to search part of the low-level index to find the reference to the list of names. And this time, we search through a small portion of the list until we find a name that matches. So the process of finding a name is more complicated. Search the high-level index. Use the reference. Search part of the low-level index. Use the reference. And search part of the patient's surname file. But the total time spent searching is much smaller, and the required name is found much more quickly. So there are two different methods used in the system to select information for display at the health centre. The list of names is retrieved using an indexed sequential method, but the medical records themselves are retrieved using the patient number index. And in each case, the computer project at Exeter chose a file organisation which matched the requirements of the job.
Computer files